Imagine building and testing an entire ESP32 IoT project before touching any hardware. Today, in just a few minutes, we will use the Cirkit Designer simulator to blink in LED, control it remotely through Blynk, and monitor live temperature and humidity data from a DHT sensor. So without wasting time, let's get started. First, open Cirkit Designer. On the home screen, you will find a variety of featured simulation projects and components. Before we begin, create an account by clicking Sign In and choosing Continue with Google. Once you are signed in, you can explore the featured projects. And various components. For this tutorial, we will start from scratch by creating a new project, and the workspace will load, ready for us to begin designing our circuit. You can now give your project a name. On the left, you will find the diagramming components, which are used to create circuit schematics only. Beside it are the simulation components that support interactive circuit simulation. You will also see separate section for parts, my custom parts and projects, making it easy to organize and access everything you need for your design. Now let's add the ESP32 to the workspace. If you prefer to write the firmware yourself, simply click Edit Code and enter your program in the built-in editor. Alternatively, you can use the AI code generator. Open the component properties, select Auto Generate Code with AI. And describe the desired behavior. For example, blink in LED with the ESP32. The AI will generate the code automatically. Once you are satisfied with it, click Add Code to the project to attach the sketch to your design. Next, let's add an LED to the circuit. If you would like to learn more about any component, open its properties and select Component Documentation to view detailed information and specification. Now connect the LED cathode to ground by simply dragging a wire between the pins and connect the anode to GPIO2 of the ESP32. You can also customize the appearance of your schematic by changing the color of the wires. Now start the simulation and you will see the LED begin to blink. Next, let's add a DHT sensor so we can monitor temperature and humidity in Blynk. Place the sensor on the schematic and connect its VCC pin to 3.3 volt, data pin to GPIO pin 5 and its ground pin to ground. With the hardware connection complete, we are ready to create a new project in Blynk IoT and link it to our simulated ESP32. Open the Blynk IoT website and click on Developer Zone. Next, click on New Template. Give your template suitable name. Select the ESP32 as the hardware and click Done. Once the template is created, open it and navigate to the data stream section. Here, create 3 data streams: temperature, humidity, and LED data stream. Assign virtual pins according to your code configuration. After creating the data streams, move to the Web Dashboard section. Now add the required widgets: a switch for the LED control and 2 gauges for temperature and humidity. For each widget, link it to the corresponding data stream so that the dashboard can display sensor values and control the LED. With the dashboard completed, we now need to create a device. Click on Devices and then select New Device. Choose from Template and select the template that we just created. Blynk will automatically generate a new device instance. Open the device information page and copy the credentials provided by Blynk, including the template ID, device name, and authentication token. Copy the Blynk credentials and paste it in the code. Now copy the code and paste it. Before we refine the code, make sure the Wi-Fi SSID is set to Cirkit Wi-Fi and leave the password field blank. Verify the sketch. Open the Blynk IoT mobile app and log in with the same account that you used to create the project. Once logged in, open the device that we will created earlier. Now tap on Edit Dashboard and start adding widgets. First, add a button widget. Next, add 2 gauge widgets. Connect the first gauge to temperature data stream and second gauge to humidity data stream. You can also customize the widget names, ranges, and appearance to make the dashboard more attractive and easier to understand. Then start the simulation. The ESP32 will initialize its Wi-Fi connection and connect to Blynk. As you can see, the Blynk IoT app now allows us to control the LED remotely and monitor the temperature reading in real time. When we adjust the temperature value in the simulator, the updated reading is immediately reflected in the Blynk dashboard. You can also export your design as a PNG image, an SVG image, or a shareable URL. To create a custom component, click Create Custom Component. Enter name, and upload the component graphic file. Next, set its dimension and define its pins. For example, here I am creating a simple 2-pin component. Select the pins, assign them names. And click Next, followed by Save. Finally, open my custom parts section, where you will see that the new GPS component has been created and is ready to use in your circuits. You can also explore ready-made design by opening the project section, where you will find a library of example circuits to study and simulate. In addition, Cirkit Designer includes a helpful AI assistant. For instance, if you ask, "How do I connect a DHT sensor?" it will provide the wiring details, configuration steps, and other relevant information to help you to build your circuit correctly. And that's it. In this tutorial, we used Cirkit Designer to simulate an ESP32 project, blink in LED, connect a DHT sensor, and integrate everything with Blynk IoT for real-time monitoring and control. I hope this walkthrough helped you get started with circuit simulation. and IoT development. If you enjoyed this video, please give it a thumbs up, subscribe to the channel and let me know in the comments what project you would like to see next. Thanks for watching and I will see you in the next video.